Hi, welcome back. This is Ms. Rubright with Advanced Geometry. Today we're learning notes on 7-7, solve right triangles. Today's lesson is just like 7.6, but with a little bit of a twist. So in 7.6, we were able to find the missing side length. Today we are going to be using the inverse tangent to find the missing angle length. So it says use a calculator to approximate the measure of angle A to the nearest tenth of a degree. We are looking for angle A. What do we have? We have opposite and we have adjacent. And opposite and adjacent we know because of SOHCAHTOA and because of the title of the lesson, that goes with the tangent. Tangent is opposite and adjacent. So tan of angle A equals opposite over adjacent. So to solve for this missing angle measurement, we use the inverse button, the inverse tan of 15 over 20 equals our missing angle A. So we take our calculator and we do 15 divided by 20 equals, and we get 0.75. Do second tan. And you're going to get that angle A is 36.866989 and so on. We want to round to the nearest tenth of a degree. So that 6 makes the 8 a 9. Angle A is 36.9 degrees. All right, so how about the inverse sine? Oops, let's use a color that looks a little bit easier to see. The inverse sine of 0.87 is going to give you A degrees. So 0.87 second sine, and you should get 60.4586 and so on. Round it to the nearest tenth. We're going to get approximately 60.5 degrees. If you are not able to get 60.5 degrees, please look at your calculator and make sure that it says DEG on it. If it does not say DEG, press the button next to the green button on your TI-30XA, which says DRG. Press it once, it'll turn to RAD. Press it again, GRAD. Press it again, it's back to degrees. Make sure you are not in radians or your answers will be different. The inverse cosine of 0.15 gives you B degrees. Let's check this one out. 0.15 second cosine, and you guys should be able to get 81.37307. Rounded to the nearest tenth. The 7 makes the 3 a 4. So it's approximately 81.4 degrees. Angle B is 81.4 degrees. Raise your hand if you're able to get this correct. Perfect. Is anyone struggling? No? We're good? Look back at example 1. Use your calculator and the inverse tangent to approximate the measure of angle C to the nearest tenth of a degree. All right, so we're looking for angle C. We have opposite and adjacent, TOA. Tan of angle C equals opposite over adjacent. So we're going to get for C, we're going to use the inverse tan of 20 over 15. So 20 divided by 15 equals second tan, and I got approximately 50.130, so it's 53, I can't even read, my bad. 53.13 is going to stay 0.1 because the 3 does not do anything to the 1. So 53.1 degrees. So for the measure of angle D to the nearest tenth of a degree. All right, so we're going to use the inverse sine of 0.54 equals D degrees. 0.54 second sine, and I got 32.6836 and so on. The 8 does make the 6 bump up to a 7, 32.7 degrees. Approximately 32.7 degrees. Solve the right triangle. Round decimal answers to the nearest tenth. So I want you guys to take a minute to try this one out. So I'm going to give you guys a couple seconds to get this set up prior to me showing you. We have a right angle, we have 42 degrees, and we have a height of 70. We're trying to solve for this missing angle here. We're trying to solve for this missing hypotenuse and this missing leg. The angle is the easiest to do, right? 180 minus 90 is 90, and 90 minus 42 is 48, so angle B is 48 degrees. Missing side lengths take a little bit more work than that. So what do we have for our side lengths? We could do this base first. We could do opposite and adjacent. Opposite and adjacent go with who? Tan. So tan 42 equals opposite, we'll call this x, over adjacent. Multiply by 70 on both sides. X equals 42 tan button times 70 equals, x is approximately, said round to the nearest tenth, 63.028, so 63.0. So we'll call this 63. And then to get our hypotenuse, we could do a Pythagorean theorem, or we could use another part of SOHCAHTOA. So if we were going for our hypotenuse, we have adjacent and hypotenuse, adjacent and hypotenuse. SOHCAHTOA. Cosine 42 equals adjacent over the hypotenuse. We'll call that y. So we'd multiply by y on both sides. Then we would divide out the cosine 42 on both sides. And we would have that y equals 70 divided by cosine 42. 70 divided by 42 cosine equals, and we get that that is going to be 94.194. 0.19. The 1 becomes a 2 because of the 9. 94.2. It said round decimal answers to the nearest tenth. They didn't round on the 94. Although your answer might be slightly different if you use Pythagorean theorem. So let's see. If we use Pythagorean theorem, 70 squared plus 63 squared equals square root 94.2. So it's actually the same. Suppose your school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. A rake, or the angle of elevation, of 5 degrees or less is generally preferred for the safety and comfort of the actors. Is the raked stage you are building within the range suggested? So what they're talking about is the slope, the steepness of the stage. If it's too steep, they're going to fall. So they want this to be 5 degrees or less. All right, so what are they saying? Suppose your school has the stage will be 30 feet long from front to back, 30 feet long. It has a 2-foot rise, and they want to know what is the angle of elevation. What is right here? What is this degree? Well, we have opposite, and we have what? What is this? What is the 30? Is it adjacent or hypotenuse? What is the 30? It is the hypotenuse because it is across from the right angle. This is your hypotenuse. We have adjacent and we have opposite and hypotenuse. Opposite and hypotenuse go with who? So, sine. The sine of x equals opposite over hypotenuse. So in your calculator, 2 divided by 30 equals second sine. And I get approximately 3.82255, so on. So this is going to be approximately 3.8 degrees. Is 3.8 degrees within their preferred parameter of less than 5 degrees? Yes. So this is a good stage. we won't get injured on this stage. Solve a right triangle that has a 40-degree angle and a 20-inch hypotenuse. 40-degree angle and a 20-inch hypotenuse. Well, if this is 40, then what's the other angle? 50, right? They have to add up to 180. 40, 50, and 90 add up to 180. So we have a missing angle of 50. What are our sides? Well, if we use the 40, we could do opposite and hypotenuse to solve for here. So opposite and hypotenuse is sine. Sine 40 equals opposite over hypotenuse. Or 20 sine 40 is that x. 40 sine times 20, 12.9. So your x right here is 12.9. We could take that and square it and subtract that from 20 squared, or 400, and then take the square root. So we'll just do a quick Pythagorean theorem to get 15.3 on this missing side. Make sense? Or we could, what is the other option? We could have used adjacent and hypotenuse. Cosine 40 equals adjacent over hypotenuse. So 20 cosine 40. So 40 cosine times 20. And we got the 15.3 that way as well. So we have 15.3, 12.9, and 50 degrees. 50 degrees, 15.3, and 12.9. In example 4, suppose another rake stage is 20 feet long from front to back, has a total rise of 2 feet. Is this safe? What is the degrees here? Well, the degrees, we have opposite and hypotenuse. Sine, so opposite and hypotenuse. Sine of this angle equals opposite over hypotenuse. So if we did the inverse sine of 2 over 20, so 2 divided by 20 equals 0.1, second sine. I get 5.739, so it's approximately 5.7 degrees. Is that safe? No, it had to be less than 5 degrees, so no, this is not a safe stage. It's slightly larger degree. It's more sloped than what they consider to be safe in their suggested range. And that is everything for today's lesson on 7.7, solving right triangles using their inverses. I hope you enjoyed the lesson. Stay tuned to our channel for our next lessons on 7.8, or actually no, this is the last section of the chapter. So for chapter 8, stay tuned to our channel. Have a great day.